going to blame the dog. It's not your fault, Happy Feet. It's my fault for getting distracted. All right. So we've got our ones and our fives. Okay. So the way we do Roman numerals is that basically it starts out fairly sane, which is that if we want some numbers like MD, CCCC, we just add up the values. So 1,500, 1, 2, 3, 4, 100. So this is 1,900 for that arch. Okay. Wait. Yes. 1,900 for that arch. Now, so that's so far. You repeat your M's and your D's and your X's. Sorry, you repeat your I, X, C's, and M's because only they can be repeated. There's no point in repeating your fives, your V's, your L's, and your D's because 2 V's is just 10, 2 L's is just a C. Make sense? So you can, and you just add them. Oh, Happy Feet. So so now here's the other rule. We put numbers in decreasing value. So 1,500's 100's over here. But notice that basically we do have a 1, 5 over here. If we write a number, to write numbers that are 4s or 9s, what we traditionally do is we put a smaller number in front of a larger number to indicate subtraction. So here we're saying 1 comes before 5, so it's 1 before 5, so we're subtracting this to get 4. So our Roman numerals are thusly. Let me share my full screen with you. Okay, so our Roman numerals are thusly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Questions so far? So let me see where did my chat. Okay, so does D represent 50? I believe so. L represents 50, D is 500. So if we wanted 40, we'd instead use the internet emoji XD for 40. Because it's 10 before 50. Make sense? All right, so what would be CCC VII? So what is this number? So C's are 300s, and this is a 5, and yep, 308. Because you've got 3 100s, a 5, and 3 8s. If I instead change it to this, $304. Right. And let's go ahead and add in, let's see, just to double check my numbers. So NL is a 50, so let's go ahead and throw that in there. So this would be 354. And now if I do this, 344, because the 10 is before the bigger number. So we subtract it. 354, 364. Okay. Now let's go ahead and start off with our first couple exercises, which is let's figure out what the correct Roman numeral for 1904 is. So go ahead and on your page, try to fill in the blank. The correct Roman numeral for 1904 is not this. So convert this value, which is 1904, into the correct Roman numeral. Hint, it's going to be a lot shorter. And then next, try translating each of these by dragging them into the right place. All right, so 1400, drag that into the right place. All right, so that's better. So about 5 minutes on this, and then I will go. And then we're going to work on a bit of the coding together because it's a doozy. Roman numerals have these rules, and they're ordered, and they make the rules make sense, but it's just an inferior rule set for numbers. Note the lack of a zero, which can be kind of inconvenient there. And can you imagine doing multiplication? I mean, just think about it. To do heavy mathematics, we had to come up with a set of numbers that enabled us to do good mathematics, to make it easy and not like 2020 level difficulty. Well, you see, the entire point of this is so that if you see Roman numerals, you can just simply run a program and it translates it for you. How are people doing on this so far? All right. So let's go ahead and, so what was the answer that you had for this one? NBC, what was this? So it was M, then 1900 would be, so we had M for, so we have 1000, then 900 is CM. So 100 before M, and then we wanted 4, which was Matt, check me. So then drop this one here, check me. So that's great. So then this one ends with an 8. So let's drag this to the one ending in an 8. This one ends in 5, LV 45. So don't even bother. Yeah, I haven't looked at these, by the way. I'm just kind of using very quick logic here. And then 2, 1. All right. So now let's go ahead and work on the on this problem. So over here, we've got quite a big program to write, or at least what I consider a big program. And actually, I think that a lot, it's even though the steps are in order, the difficulty and the order in which we should implement are not necessarily the steps they're giving us, which is a bit tricky. So Okay, so now that we are now experts in converting these things, let's go ahead and write a program that takes any Roman instead of Roman numerals and converts them into, you know, our standard Arabic regular numerals. Okay, so the program should do following. Ask for a Roman numeral. That's fairly easy. That's just an input statement. We're going to leave that for last because otherwise it's going to slow down our testing. Okay, always leave user input for last because it just slows it down your testing. Number 2, validate the number to make sure it follows all 4 of those rules. It says I don't care what rule violates, just make sure it follows all the rules. 3, if it's valid, convert it to the Arabic number and then print it out. 3 and 4 kind of go together. That's no problem. So, and then validate the number to make sure it follows all the rules. That's actually the most painful part, I think. Okay. So first things first, I'm going to go ahead and load my history here and share this bit because it says, hey, you want to start by using a dictionary to map each single character to a Roman numeral, from a Roman numeral to the correct Arabic number. Okay? So M to 1,000, D to 500. So here I went ahead and wrote a dictionary just to store these values so I don't forget them, right? M is 1,000, D is 500, C is 100, L is 50, X is 10, V is 5, I is 1, right? All those values I already wrote down in a dictionary. So if I want to know what value M is, I just simply say D M, and we would ask, hey, can you give me the value of D of this single? Now this only works for single letters, by the way. So, boop, and it will tell me 1,000. So it only works for single letters, right? Makes sense? Okay. Now let's go ahead and, so that's just going to be there for convenient. I've already shared it, so you can reload and load your history over there if you want, or you can write it out yourself. It's no problem, but that's a dictionary, right? Key is the single digit Roman letter. So the key is the Roman letter. The value is whatever it translates into Arabic for. Okay. Everybody cool on the dictionary? Let's see. So I'm going to write, so essentially, so let's go ahead and just write a step for step 2. Validate, which given a Roman numeral validates it to make sure it's going to pass the rules. And for right now, I'm just going to say return true because I'm lazy. I'm not going to bother doing that at the moment. That's for later, figuring out if it does that. Because fortunately, we can just assume that it's true for step 3, which is we'll create another function, def convert. So given Roman, convert, give me back the number, its equivalent number, which I'm just going to return -1 for until I'm done. I like to use returns or passes as placeholders. I'll replace them when I'm done, but I always like to make it so that my code will always run. Okay. So let's think about this for a second, right? And think about how the rules kind of influence this, right? We know that we're going to be going from larger number to shorter number, right? And we add them up, but we can't just straight up add everything, right? We can't do 1,000 plus 500 plus, well, we can't do 1,000 plus 500 plus 100, 100, 100, 100, right? And then plus 1 plus 5. We would get 1,906 rather than 1,904. So the key to solving this actually, and this is what was giving, and this is what gave me such difficulty, is to realize that subtraction is actually fairly straightforward, right? Which is that what we do is that we use this negation rule. Anytime a number is to the left of a larger number, so we have some smaller number to the left of a larger number, right? All the numbers should always be greater than or equal to the number following it. But if you find a violation of that rule, that means you subtract. Does that make sense to everybody? So, for instance, in this case over here, we want to add. We want to do 5 plus 1. In this case over here, 1 plus 5, or we don't want to do 1 plus 5. We want to do 1, and because it's smaller, here we're doing 5 plus 1. Here, this 1 is actually a negative 1. For this one, yes, this would be invalid, but it was a convenient example because it was just lying around. Okay. So numbers are only out of order for this special negation rule. Okay, so let's go ahead and convert and think about how to convert this. So since we're going to be looking to the number to the right of me, right, I'm going to be looking at each number. I'm going to be looking at each number to the right. Make sense to everybody? So since I'm looking at this number and I'm going to be looking at the number to the right, I'm going to have to use the index. So for I in index, for index in range, length Roman, okay, what I'm going to do is basically I'm going to get the the letter is equal to Roman at this index. And then next is equal to Roman at index plus 1. So what's the potential problem here? Kind of already wrote a mistake here. That's right, index out of bounds. Right, anytime when you're dealing with indexes and going over the thing, if you do index plus 1, you're going to go out of bounds, right? Because what's going to happen, you're going to get to the next number, right? So say I'm doing this, I'm doing VIII, right? So this is letter, this is letter, this is letter, this would be next if this is letter. So now we go over here, this is letter, next is out of bounds. So what we're going to do is we're just going to exclude the last letter. And because the last letter is always going to be by itself, right? Like a 5 or a 1 or whatever, or in this case, MCD, because we know this last letter is always going to be greater than everything else, we can just add it. Or it's going to be great. It's going to be greater than everything to its right, which is nothing. So let's go ahead and do Arabic is equal to 0. We'll do our loop. Let's see. Do cool stuff here, right? And then we're going to do Arabic is equal to, well, we want to get the last thing in Roman. So Roman minus 1 is the last thing. And then to get the thing that we want from it, actually, I'll break this up into multiple statements just to make it easier to read. Last letter is equal to Roman minus 1. Arabic is equal to the value of last letter. Could have done that in one statement, but there we go. And there should be plus equals over here. And then we'll return Arabic at the end, assuming it can spell. So right now, all this should do is print out, MM. So instead of printing out 2000, this should print out 1000 because it's only grabbing the last letter. If I do MI, it's just going to get that last letter again. Let me go ahead and share what I have with you guys. Okay, so what is the cool stuff I'm going to do here? Yeah, the dictionary is a global variable, so we can grab it, no problem. And we did. So you can set up global variables like this to exist outside of functions if you have multiple functions that need to use them. Okay. So what we're going to do over here is now I'm going to give you the chance. And let's just think about what we want to do here. We've got our letter. We've got our next letter. It's fairly straightforward, actually. If the current letter is greater than or equal to the next letter, then that means that letter gets added to our Arabic total. Otherwise, if it's less than, and we don't really need to check if it's less than, we can just simply say else. Otherwise, it's less than. Therefore, subtract it from our Arabic total. So go ahead and try to complete that statement. And then we will turn, excellent, good eyes. So Python is a cool language in the sense that it allows you to, is that you can use some words like next have special meaning in Python, but if you just go, some of those words, if you set them into variables, Python's just like, okay, but just letting you know that word does have special meaning, so you won't be able to use it with its special meaning here in this function. Let's find out, can we do print is equal to X? Or let's say, apparently you can. And as you can see, this can lead to some very strange issues. Python is a very flexible language. It assumes you know what you're doing, even if you don't. Mm-hmm. All right. So I'm going to let you guys work on it. I'll be back with another animal. So how is everyone doing on this one? This is Molly. She is one of 3 cats that I have. So I have a dog and 3 cats. They're all sisters from the same litter. That is true. Molly does not have any love on the Canvas page, but that's because she does not like to sit still for photos. That's a lie. You do sit still plenty of times. Molly's a fairly friendly cat. If you, although she'll warm up after a couple hours to a particular person, but Murphy, my other cat, is very friendly, almost dog friendly, but she does have opinions about being carried. No, I don't want any more dogs. No. I am good with my animals. They were all rescues. So I have a 3.5-year-old. I'm good for chaos right now. All right. So let's go ahead and work on our so right, index out of range over here. You want to make sure that you've got this -1 over here. So let's go ahead and basically get the values. So D letter is greater than or equal to D next then Arabic plus equals D letter. In other words, if it's in the correct order, which is bigger numbers to smaller numbers, then we just add the current letter, Otherwise, if we've got something out of order and we're assuming that it's all correct, that follows the rules, then we'll just simply we subtract our current letter instead. And this is going to assume that the rules are followed. So this should be 1001, MCI 1101. Let's go ahead and do, so now we've got 1111. And now if I do this, right, that's fine. However, if I did this, yeah, it seems right. Although I think it would be technically be this, right? MCXIX, right? Because, yeah, MCM. We don't do CMM. So plus equals does, yeah, plus equals increments this by this amount. It is the same as saying this. And minus is the same, but with a minus sign. We don't need an if-else condition for checking if it's out of bounds because I'm preventing it from going out of bounds right here. So this is why I think this one was used as an interview problem quite a bit, is because now once we get to the validate, there's actually a lot of depth here in trying to get the rules followed. So first off, we know that basically that you can only have any variable in there, any letter in there 3 times. right? So let's go ahead and check out validate. So, so we can only have any number there 3 times, up to 3 times. So let's say if, I'm going to be lazy, 4 letter in Roman. If Roman dot count of that letter is greater than 3, return false. So this will, so what I can do here now is start validating stuff. So right now it's going to validate pretty much anything unless it has more than 3 of a specific letter. True. share. True. What about CM? Or would it be CM? So let's see. CM. False. That should be valid though. So this is why I say there's a lot of depth here because, right, if I wanted to do 39, if I want to do 39, this is the proper way to write 39. So I can't just, so they've got to be repeated up to, so yeah. So yeah, what if they're not in a row? Can you have a Roman numeral that, you can have a Roman numeral that repeats, so you can have a Roman numeral that repeats 3 times, and then you also have the the negation issue. Tricky, tricky, tricky. So I can't just count them, right? So this is why it's a fun one, because there's a lot of depth to validation, right? So let's go ahead and think our way through this. And please, I'm not actually entirely fully sure how to do this. I've got some ideas. I don't know if there's elegant ways to do this. But one thing we could do is make use of slices, right? We can make use of slices to make sure we don't have 3 in a row rather than 3. So let's instead go back to use this loop over here. Slices here are going to be fairly straightforward to do, though. Slices are a super useful tool. And in fact, I'm going to go up to the end because using slices make this so much easier, actually. So let's see. So here I'm just going to check to make sure that no more than 3 in a row occur, right? Which is 4 index. So 4 index in range length Roman. What we're looking for is basically 4 letters in a row. So 3 letters in a row, that's okay. 4 letters in a row, no. So 4 index in range Roman. Let's go ahead and see. So let's go ahead and say our slice is equal to Roman and slice from our current index to 4 past our index. And yeah, Katrina had a much better idea, I think. But I'm going to finish this one up anyway. So we've sliced this, and if letter, so if SLC equals Roman index times 4 return false. And basically we're saying if this slice is equal to 4 in a row, return false. But I like Katrina's better, which is much simpler to understand, which is for letter in Roman, also shorter to write, if letter x4 in Roman, return false. So there, that validates the true. Now, of course, some jerk could point out that there's nothing preventing us from doing that and it validates that, but we aren't done writing the validation function yet. Excellent question. So no, you would not have to account for times 4 times 6 because times 4 is a subset of times 5. In order for there to be times 5, there would have to be a times 4 replication, right? In order to have I, 5 I's in a row, you'd have to have 4 I's in a row. So now in this picture, so validate it. So so we've done this one. Repeat it up to 3 times. Only I, X, C, and M can be repeated. V, L, and D should not be repeated. So this one's actually fairly simple. There's only ever going to be, let's see. Is it? Yeah, it's not going to be repeated because you're only ever going to have like one V in here because, right, VV, that's 10. And you might go, well, what about 9? IVV? But how would you write that instead? What's the better way to write that? Well, any 2V should be NX. So IV. So let's go ahead. So this will help cut this down. So if count dot, so this one's actually fairly straightforward to run, right? If Roman dot count of V is greater than 1. So if we have more than one V, or we have more than one X. So what was the other? Right, L. More than one L, because 2 L's is equal to 100, or more than one D. Return false. And yes, I know I'm doing a lot of this, but it's because if you notice, I am actually asking the class and we're getting answers back here, which is very interesting, which is a good experience for us. So return false in this case, right? If the count is just bigger, if the count is bigger than any of those, then okay, it's repeated. Writing numerals creates additions, and then we have the negation rule. So let's see. So let's go ahead MC. Now this probably will this will still validate that. What about MMMMM? That should give us false because we check for every letter, we check to see if that letter replicated 4 times is in that. So the only thing that we seem to have left is this weird case where basically we do say MMM, C, MMM. What about if letter is in VLD and letter times 2 in Roman? Well, we could do that. So the question is, what if we did, and I'm just going to copy this over here. What if we tried this instead? And the answer is, well, it's because I'm being a bit stricter here, is not just a matter of having two V's in a row. I'm saying there can't be two V's in a Roman numeral period ever. So this should validate. This should crash, or not crash, but it should say basically that it's not no bueno. All right. So any ideas how to prevent me from doing my shenanigan statement of CCC, ICCC? Or is it technically okay according to the rules? Because it looks like it's technically okay to the rules that they've spelled out to us. Writing values that decrease in values. So rule 1 is repeating up to 3 times represents the number of additions. So you can do 1, 2, 3. So here, repeating a numeral up to 3 times represents addition. So here, what we're saying is that we can repeat a number only up to 3 times. So we can have I, we can have 2, we can have 3, but you can't have 4 in a row. Okay, makes sense. You can't have 4 in a row. To do 4, you instead have to do this. Rule 1 only says basically making sure we check for this, or this, or this, or this, or this, or say this. So the way we check that is that we look at every letter in the Roman numeral representation, the Roman representation of our number, and we say for every letter in that representation, let's go ahead and basically multiply it by 4 to make it not the value, but the string. So if the number is I, then I'm going to turn it into I. Then I'm going to ask, is that in there, right? Is this letter repeated 4 times in a row in there? And then for over here, I'm just counting, hey, do these numbers occur more than once? Because that can't possibly happen. Now, with it being 253, I'm going to move on to the next part, which is going in the opposite direction. So over here, they did some funkiness over here. Can you write a program that goes in the opposite direction? Given an Arabic numeral, you can convert to a Roman numeral. This gives you a special type of dictionary that preserves the order of the dictionary. So you can go, so if you do a for loop over the keys, you'll get them in the same order you create them. So for instance, if we do a for loop over the keys in Roman over here, it would be 1000, then 900, then 500, then 400, then 100, then 1. In older versions of Python, that didn't used to be guaranteed in Python. So if you were using before Python 3.6, then the keys wouldn't necessarily appear in order. That's changed to be the default behavior in Python 3 and 6, but in the browser, so just know this is a dictionary, and this is how they do the dictionary in the web browser, at least, for this specific problem, okay? So don't get too scared about this. This is just simply them doing a dictionary. They're just representing it a bit differently, in different format. So they're creating this ordered dictionary. So where they've got not just 1000 and 500, but they've got the 900 and 400 in here. So put in the missing entries, and then any ideas about how to go from Arabic to Roman Any ideas? Because fortunately, we don't have to validate our Arabic numbers. So how would we go about doing this? Everybody's being shy in chat. Modulus and division, we would split into places. Landon, that is a stab in the general direction. That is the correct direction to go. It's not the correct answer, but it's the correct direction. Modulo and division is a good guess, but we don't really need to use it. I don't know if we necessarily need to use it here. We're going to take advantage of the fact that we've got this ordered dictionary, in fact. And what we can do is that we can basically say, so long as this value, so what we could do is say like, okay, suppose I've got, well, actually, let me go ahead and show you the mental algorithm I have by doing it myself. Okay. So we've got 3,000. So let's take a look. We've got 3,914. The biggest digit that I can subtract from this is 1,000. So I'm going to do so. So now I'm left with this much. I'm going to go ahead and subtract. 1,000 is the biggest I can subtract from this. 1,000 is the biggest number I can subtract from this. 900 is the biggest value I can subtract from this, right? So what is 900 is cm, by the way. 10 is the biggest value I can subtract from this. And then 4 is the biggest value I can subtract from this. Let's go ahead and change this up into something. What about 2,890 and 59. Okay, let's go ahead and subtract 1,000 from this. So that would give us an M. The biggest Roman numeral I can subtract from this represents 1,000, so I'm going to do so. The biggest Roman numeral I can subtract from this one is what? $500, that's right. So 500 is D, so I'm going to subtract 500 from this. So now the biggest Roman numeral I can subtract from this is 100. It's a C. Biggest Roman numeral I can subtract this is 100. Biggest Roman numeral I can subtract from this is 100. 5. 5 is subtractable. So that's 59, which is, so subtract 50. What is 50 again? 50 is L, and then 9 is XI. So everybody's kind of got to grasp my algorithm. What I'm doing is I'm like looking at the number and saying, okay, which Roman numeral can I subtract from that? But actually, computers have the advantage of that, basically that we can just keep subtracting. We can go. So let's go ahead and I'm going to give you the start of this. So for num in Roman.keys, let's go ahead and print num, and I'm just going to make sure this works. Okay, yeah. So we need to fill in the rest. What I'm going to do is I'm going to put in, so for each of those, I can't just subtract it once, write an if statement. Instead, I'll use a while loop inside that for loop. And I'll say, while this number can be subtracted from this number, then do so. So go ahead and take a bit to try to solve that. And I'm going to try to corral another cat. This is Murphy. She is my biggest cat. Yeah, she's gotten a bit heavy over the years. Um, she is super friendly, like dog level friendly. Um, she's fearless, and she is, like I said, really friendly. She acts like more like a dog. She'll fetch. And you're digging your claws into me. Why are you digging your claws into me? Are you telling me you don't want to be this? No, she's mine. And Laser really likes her too. Very tolerant of having of a toddler using her as a pillow. Very, very, very sociable cat. Who? What? Seriously, cat. Why are you trying to dig your claws into my bare skin? That's just your way of telling me that you've had enough of me. Cinnamon? Cinnamon is my other cat. So my third cat is nocturnal. She will not come out from under the bed. She just doesn't come out from under the bed until like 9 o'clock when Laser's safely asleep. She does not like children. There's some days where I feel that. So Cinnamon is she's did not like the drive from Atlanta to Philadelphia. That was a number of years ago. Yeah, Atlanta. That's where we came. That's where we lived. I moved up to Pennsylvania in 2016 to take the job at Temple. It was a bit of a drive. Honestly, I like it better up here. Transportation is better. The mass transit is better. It's more compressed. It's easier to get to places. The heat is honestly not different in the summer. Although I think it's worse. No, it's worse in Atlanta. It's just Philadelphia is getting. Yeah, this weather is nice. It's not. All right. So while everybody's working, I should mention that I'm currently working on quizzes 4 and 5. I feel that what we've been doing is big enough that it should be split up into multiple exercises so you don't feel so panicky about it. So quiz 4 is going to be solely over files, and quiz 5 is solely over quiz 5 is going to be over dictionaries. You don't get any snow in Atlanta anymore, just none. And the weather's really not so bad in my opinion. I don't mind having to dress up too warm. In fact, being warm lets me when it's cold, I get to wear the stuff I want. Yeah, it is inconsistent right now. Every day is an adventure with weather. But Atlanta is just a hot and muggy mess. No, 4 and 5 will quiz 4 and quiz 5 will be due at different times. So I'm writing quiz 4. It should be up like this afternoon, and it's probably going to be due next week. And then probably there'll be a couple days lag between them. All right. So let's go ahead, and now that you've thought about it, so the rest of the ideas that we have to do over here, the rest of what we have to fill in over here is fairly straightforward. So what we're going to do is that we needed a 90 over here. So 90 would be XC. We need a 50 over here, which would be L. We needed a 40 over here, which would be XL. And then we needed, yeah, so it's 10, 9, 5, 4, 1. 10, 9, 5, 4, 1. So now we've got 10, and now we do 9. So what is 9 is XI, IX, yeah. V. IV. And thank you for typing that out, but you know, I think I've at this point, oh well. So yep. So that's what happens if you don't have a pass, by the way, over there. Just to like cap that out. So, all right. So for each number in the Roman numerals, let's go ahead and put our, so they call this Roman. So I'm going to call our output. I'm going to call what we print output. Make sense? So this is what we do. We say output is equal to the empty string because we're going to accumulate on this. So for the number, okay, while, let's see, while num is greater than or equal to, let's see, so for number in the Roman keys, actually no, so while number is, got my variables mixed up here. So the number is, what is our total? Oh, we don't have an input yet. So let's go ahead and say our input is going to be called Arabic. I'm not going to bother taking user input, save us time. Okay, whatever, just type in some numbers over there. 2, 3. So while Arabic is greater than or equal to our number, output plus equals Roman, the Roman numeral, and then Arabic is equal to Arabic minus number. Wow, that's much easier now. That's cool. So everybody see, so any questions about how this works? Because I realize that's like a what? Right? Because anytime I throw a while loop inside a for loop and throw it to freshmen, a lot of them are like, what? No, why would you do such a thing? That's okay. I mean, I share this one above one. And then what was imported at the top? Import from collections, import this. Okay, so other questions from the chat. Can there be more than 3 M's? Well, at some point there's going to have to be more than 3 M's if we want to do 8,000, right? Otherwise, we have an upper limit. So now also, so let's see. Meet asks, what is dot keys? So this is just, so dot key, I think you mean dot keys. This gives us, this is just me being explicit that I want to iterate over the numbers over here, which is 1,000, 900, 500, 4,000, 400, 100, 90, 50. This is the default operation when we iterate over a dictionary, which is to iterate over the keys as opposed to the values. So here I'm just saying I want to iterate over the keys. So now can I explain the while inside? So what we're doing over here is that basically we're saying, essentially, so let's go over here with 2324. So I'm saying that basically for a number in the Roman keys, and it will keep it in this order, which is, so first we look at 1,000 and we say, while the number is greater than or equal to 1,000, that means I can subtract 1,000 from our Arabic number. So I do so, and because I've subtracted 1,000, I output an M. Then, so we're left with 1,324. Is it possible you have an infinite loop? So next, we're at 1324 with an output of NM. So we subtract 1,000 because our number is greater than 1,000. So we subtract 1,000, output another M. So we're left with 324. So Arabic. So now we go and check 900. Is 324? Wow, 324 is greater than 900. That doesn't run. While 324 is greater than 500. That doesn't run. While 324 is greater than 400. That doesn't run. 324 is greater than 100. So while 324 is greater than 100, we subtract 100, output a C. Subtract 100, output a C. Subtract 100, output C. While 24 is greater than or equal to 100. Sorry, 24 is greater than or equal to 100. Yeah, that doesn't run anymore. We stop there. So then we try 24 versus 90, 24 versus 50, 24 versus 40, 24 versus 10. So with 10, we subtract the 10s and put out the X's. And then finally, with 4, we output we just output IV. Does that make sense? Here, what we're doing is that the while loop is acting like a repeated if statement. Here the while loop is acting in a very natural form, which is we want to ask an if statement multiple times, which is how many times can I subtract this number? Tuple object is not callable on line 4. Did you remember to have your parentheses? Do you have your parentheses and all the like in the right place? Right? Do you have ordered dict, parentheses, bracket, and then, yeah. So, Yeah, this is a funky dictionary that so just make sure you have this. I did share the code, so you should be able to refresh your page and load the history if you want a copy of it. Don't worry, I make that mistake tons. The only time the only reason I didn't make the mistake this time is I was being exceptionally sure to look out for the commas. And I only knew to do that because I've made that mistake a bunch of times, not with specifically this, but others. So, all right. I think that is a good place to stop for today. Answer the short answer on your own, please. So do your best to answer the short answer on your own, and I'll be interested to see what you did. I did share the code for both of them, so you might have to refresh the page. I will be able to stay behind after class. So as far as I'm concerned, class is dismissed. I'm going to stop recording.